also going to offer this time for you to ask questions and get information that you need from this event. So I'm going to turn it over to Katul so he can introduce himself.
Thank you, Robin. Welcome, everyone. My name is Katul Popat. I'm a professor in mechanical and biomedical engineering, but I'm also the director for undergraduate programs in biomedical engineering. I actually also teach the freshman introductory course in biomedical engineering. So, when you guys come here and when you join our program, the first course that you would take would be with me, which is the introductory course in biomedical engineering in fall. In a bit, we'll talk a little bit more about, biomedical engineering, but I think we'll go ahead with Katie, and she'll introduce herself.
Hi, everyone. My name's Katie. I'm currently a 5th year student studying chemical and biological engineering with biomedical engineering. So I had Dr. Popat my first year. And yeah, thanks for joining us. I'm really excited that y'all are interested in biomedical engineering. I might be biased, but it's awesome. So yeah, I'll turn it over to Robin.
Yeah, we're all very much biased here, so we will all share all of our amazing things that we do. But like I said, I really hope that this is a chance for you all to get what you want out of this session, a chance for you to learn about us, because we can very easily kind of be talking heads and share a lot of information that we feel is important, but it may miss the mark on what you feel is important. So please, at any point, if you've got a question, you can raise your hand, you can drop something in the chat. We'll make sure that we're kind of paying attention to that and monitoring that. But I do want to take a moment to just kind of offer a little bit of space, rather than, I said that maybe we'll have you introduce yourselves, but I think sometimes in an informal setting like this, it can be a little bit overwhelming. So rather than having you go one by one and introducing yourselves, what I'm going to do is I'm just going to create a little bit of space here for just a moment and just see if any of you have some questions that you really want to make sure that we touch on and address for today. So I'll give you a minute, so I'll just ramble for a second while you think of this. But if you do have, if there's particular things that you want to make sure we touch on, if you have any burning questions about biomedical engineering, why don't you throw those out right now? Either you can just unmute yourself or put it in the chat. And if you have those questions, then we'll make sure that we touch on those and address those. So I'm just going to create a teensy bit of space for that. All right, so I don't really see anything in the chat. Not anybody's really unmuting right now, which is totally fine. So just assume that what we have to cover, you're excited to learn about. And maybe as we touch on information, it may kind of spur some of those questions that you have. So again, at any point, if you feel like you really do want to ask questions, you've got something that you want to make sure we touch on, please, again, unmute yourself, put something in the chat. You can raise your hand with the reactions down at the bottom of your meeting, and just please make sure that you're getting the information that you need. So I'm going to share my screen, and we've got some information to share about what biomedical engineering is and some of the highlights of our program. So let me get to that really quick. Always going to make sure I'm sharing the right information. All right. So Katie, can I get from you, are you seeing our PowerPoint for the biomedical engineering?
Yep, looks good.
Okay, all right, perfect. So Katul, I'm gonna have you go ahead and start, and anytime you want me to jump in, just let me know.
Cool. So, the next, maybe 15, 20 minutes, I think our goal is to kind of introduce you guys to what biomedical engineering is. Some of you may actually already know about it. But maybe this would add to what you already know, and for those of you who don't know anything about it, hopefully this would make you even more excited to start your degree program in biomedical engineering. So one of the main goals in biomedical engineering is to solve technical problems to improve health. Now, what does this actually mean? This could mean things like, how do we improve implants which go in patients? How do we improve instruments which are used to diagnose disease and things like that? And biomedical engineering is a very multidisciplinary field. Apart from engineering, you do need to know a little bit about biology, Well, medicine, we don't really train you in medicine, but at least we give you experience of working on projects which are medical related. And combination of engineering with biology and medicine is what biomedical engineering is about. And so when you study biomedical engineering, you'll actually have to study some basic science. So you'll have to know some chemistry, you'll have to know some physics, you'll have to know some math. And believe me, you might think, what does math and physics and chemistry have to do with this? Well, in a few years, once you're in the program, you'll realize that there is so much that you learn from math, physics, and chemistry that could be applied to solve medical problems. You'll have to know a little bit about biology. You'll have to know about medical applications. And, we do train you, and we do have courses that actually, kind of talks about, what kind of applications, are important. But overall, I think engineering is something that is sort of the core to what we do in biomedical engineering. And what I mean by engineering is not just one engineering major. I think you will have to know about different engineering majors, and that's the unique thing about our program, where you're not just going to learn about biomedical engineering, but you're also going to learn about your partner engineering major, which could be either mechanical, chemical or biological, and electrical engineering. And so our program is very unique in that way, because we kind of train you not just in biomedical, which is important. You need to know about biomedical engineering, but a lot of the problems that you will be working on in biomedical engineering would either be mechanical related, chemical related, or electrical, or it could be a combination of all of those three. The goal of engineering in this medical field is to sort of come up with creative solutions to solve these complicated health problems. I mean, doctors, they know how to treat certain things, but we always have to figure out, or we always have to think about innovative ways in which we can make things much simpler for these doctors to treat. But at the same time, we want to make sure that patients who are getting these treatments and therapies, they can still, recover faster and still have a healthy lifestyle after that. And so everything that we do is about making lives better for people. Next slide. So, there are many different topics in biomedical engineering. This is just a very short list of it. These are some of the things that you will learn about throughout your 5 years when you come here. But some of the cutting edge research which is going on these days in biomedical engineering is in artificial organs, in how do we make implants better so that people can walk and run and do physical activities better after traumatic incidences. Pharmaceuticals is a big area. We all know right now what we are going through, how important engineering is now in terms of, making, drugs. Discovering drugs, is different than making drugs. Somebody can discover the drug, but how can you make it effectively? That's a whole different thing. That's a whole different engineering problem. And so there's a lot of research going on in that. Point of care diagnostics, how can you design, systems with which you can test for certain disease very fast, very quickly, and very accurately. So this is just a very short list of, all these exciting things which are going on in biomedical engineering. And a lot of this is going on here at CSU, where a lot of faculties are involved in doing research on some of these topics in their labs.
And before we move on to the next slide, I'm going to put you on the spot, Katie, if you don't mind. The list that we see, these exciting topics in biomedical engineering. I imagine that some of you that are here with us today have a few of these things that are on this screen going, yeah, these are things that I'm excited about. So my on the spot to you question, Katie, is there something on this list that you kind of saw that you originally thought this is exactly what I wanted to do? And how is that still something you're interested, or has that changed?
Yeah, so I kind of have two parts to answer this. So the reason that I actually got into this program was for neuroengineering. I've always wanted to work on research for neurodegenerative diseases and trying to, treat people with those diseases because they're so detrimental. But any of these categories kind of go into that same overarching goal of helping people have a better quality of life and treating people that have different diseases, which I love. And that's definitely something I'm still really passionate about. But in my 5th year, I've actually become really interested in point of care diagnostics. So my senior design project is all based on point of care diagnostics, and we're trying to create a paper-based device that can detect RNA viruses. So something like COVID-19. And this is a way that you could test a lot more people really quickly. It's a lot cheaper, and it can be used in areas that don't have any kind of laboratory equipment available. So this was kind of an area that I got into through the program that I didn't even know kind of existed coming into it my first year. So kind of like Dr. Popette said, there's a lot of ways to learn about many different things in this field, even if you are just in one specific partnering discipline, because the point of care diagnostics has chemical applications, but it also is kind of mechanical as well. And so lots of different ways to get involved. And these are still things that I'm very passionate about, especially that neuroengineering piece. So.
Cool. Thank you so much, Katie. I also want to create a little bit of moment. What are some of the things, so if y'all would just want to unmute yourself and you can shout out and share, but what are some of the things that you see either on this list or not even on this list that you're excited about or interested about in biomedical engineering?
And you guys can type into, and I know we have a few questions. We'll get to that towards the end.
I'm definitely interested in robotic surgery and the technology that goes into that.
Cool. And there's so much that's advancing with that. That's really cool. Thanks so much for sharing, Jackson.
Definitely neuroengineering and prosthetics.
Cool. And I love hearing these stories too, because then we kind of hear a little bit of that crossover too of what brings us to this interest, but also as you're sharing, Katie, just kind of how things grow and develop, but like just that crossover and that interdisciplinary nature. So thanks for sharing, Sierra. Anyone else?
Definitely biomechanics and prosthetics.
Cool. Yeah, thanks, Mark. Yeah, that oftentimes you get a lot of students coming into our program really have that interest, and really a lot of folks just that's kind of the one big thing that you really know about biomedical engineering is this kind of category of prosthetics, and how that changes over time and kind of your connection to that and your knowledge with that is just how that grows within your discipline is really cool to see. All right, anyone else? Cool, thanks for sharing. All right, I'm going to turn it back over to you, Katul.
Yep, yeah. So, our program, I think I already mentioned this, that it's a program where you will get 2 degrees, you'll have 2 majors. You'll have biomedical engineering as one of your major, but then you'll also be getting a degree in a partner major. So you actually do get 2 Bachelor of Science degrees. Depending on what partner major you choose, you will either be in mechanical, chemical, and biological, or electrical. And also in electrical engineering, there is a further split where there is a specialization in laser and optics, which is another exciting area, a very upcoming area in biomedical engineering, a lot to do with imaging and microscopy and things like that. So one of the obvious questions that we get is, why get 2 degrees? Well, not that, we want to make it, well, we would like you guys to stay here and spend a lot of time with us, but at some point you guys have to graduate and leave. So that was not the reason, but the reason was that, a lot of feedback that we got from our industrial partners and our industry advisory board indicated that, just having a biomedical engineering degree was not sort of, well, it's not sort of enough to kind of go into, one of these areas that we just talked about in the earlier slide. Getting trained in a traditional engineering degree, makes you sort of more versatile, makes you sort of more appealing to industry because you do have some unique skill sets now. Very few, there's hardly like 2 programs in the whole country where, there is this kind of a dual degree or 2 degrees where the students receive. So once you graduate, you will have this unique skill set of not just knowing biomedical engineering, but also knowing about, your partner major. And so our approach is sort of a T-shaped where, you are going to learn about some basics in your first 2 years about biology, physiology, chemistry, physics, math. You'll also be taking a lot of courses related to your partner major. And then eventually when you come in your 3rd year is when you would have some courses related to sort of hands-on experience in biomedical engineering labs. And then the best thing, and Katie can talk more about it, one of the best thing that we have in our program is our senior design, where students actually work on real problems. These real problems are the ones which have been given to us by industry. So we are not, just making those up. It's like real problems that companies face. And they just want to, get involved with, with students and get new and fresh ideas of how they should solve these problems. And so they come to us with all these projects, and then we have our senior design students who work on these projects. So even though this is a 5-year degree program, you'll probably be taking a lot of credits, about 156, 57, 58 credits, depending on, what courses you take. But every single credit is worth, because once you're doing your senior design, you'll see all things coming together, all your math and chemistry and physics, all your partner major, all the biology, physiology, all comes together. And now you're focusing on solving this real world problem that, if successful, is going to change people's lives. And that's what, everything is about. So as I mentioned that, you get 2 degrees, and I think I already talked about this, but, just to give you guys, a snapshot. So you will get a degree in biomedical engineering, but you'll also get a degree in chemical and biological, electrical, and in electrical, you could choose the laser optics concentration, or you could get mechanical engineering. Now, our program attracts the best of the best students, and we get, full very quickly. So apply early. And especially if you are going to choose biomed mech, biomed doesn't have caps, but mech has, and so we have to follow that. And so the caps can reach pretty quickly if you don't apply. So, apply early, and as you go through the process, and if you have any questions, we are always here to help you. We are always here to help you to kind of pick what do you think is the best partner major for you. We are always here to help you, but apply early, because we really want you here, and we don't want the cap to be the restrictive part for you to not be here. So, apply early. So as I mentioned, before, why 2 degrees? So obviously we have industry, and in our industrial partners have indicated that this is something which is a very unique skill set that the students would have it, and they would be very desirable in the job market. But also, the Bureau of Labor Statistics, about a couple of years back predicted there is a 5% growth in biomedical engineers in 10 years. So if you think about, in next 10 years, there's going to be constant increase in the demand for biomedical engineers. And the industry has told us that they do want, engineers who are trained in some unique skill sets. And that's what we do here. So, we give our students the kind of skill sets they need so that they could go to a company and fit right into that company in working on biomedical engineering problems related to, whether it's materials or mechanics, or whether it's pharmaceuticals, or whether it's, working with, diagnostic machines and tools and things like that. Okay. So we're going to have a quick quiz.
Just what everyone wants to hear, right? Congratulations, you're learning. Quiz time.
So we're going to show you some, cool pictures about some cool things in, biomedical engineering. And you guys have to tell us which of the partner major that we just talked about in the couple of slides back, or maybe the last one, relates to this. So first of all, do you guys know what this picture is?
Are those artificial joints?
Yes. It's actually a hip joint. So can you guys think about what would this fit? How is the partner major, which partner major is related to this? Come on, it's pretty easy.
Mechanical?
Yes, it is mechanical. Because you're trying to design something which is going to support, and so there's going to be a lot of forces and everything that's going to come on this implant, so it is mechanical. But let me tell you this, it's not just mechanical. There's a lot of chemical engineering here as well, because you're going to work with materials, and materials do come in mechanical, but materials also do come under chemical engineering. So this kind of gives you an idea that it's not just that if you do mechanical, you have to work in this, or if you do chemical, you can't work in this field. You can still work in this field, because these problems that we are dealing with are so complex and they're so multifaceted that you will find that your background and your expertise is going to apply to these. So let's look at the next picture. Do you guys know what this is? Anybody?
I'm gonna guess either pacemaker or hearing aid.
Pacemaker, yes, that's correct, pacemaker. So what do you think this is going to fit now? Which of the partner majors?
Oh, definitely electrical.
Definitely electrical. Yeah. Let's look at another picture. Do you guys know what this is?
This is always a tough one.
This is always a tough one, yeah. Any
This doesn't
guess?
go inside the body, right?
No, this doesn't go inside the body. No. So it's too complicated to be inside the body.
Yeah. Yeah.
And that's a good point, actually. Biomedical engineering is not about everything that goes inside the body. There's a lot of things that happen outside the body where biomedical engineering is involved, and this is one of those examples where it's not going to go inside the body, but it's going to come in contact with biological fluids. So any guess? Not even a wild guess.
So let's go with the partner major. Process of elimination. I'll bet someone could get what partner major this might be. No takers.
So this would be part of chemical engineering. And this is a device which is called a membrane oxygenator. This is something through which you would actually add oxygen in blood. So when they do, bypass kind of surgeries and things like that, they will have to use something like this to add oxygen into the blood, because obviously the person who's going through surgery is not really breathing. And this is a very classic example of a lot of the things that happen in chemical engineering. In chemical engineering, when you make chemicals and you're trying to mix them and you're trying to separate them and you're using, filter systems and membranes and things like that, it's very similar to, this membrane oxygenator. So, but, as Robin said, this is always the hard one. So it's okay if you didn't get it.
Do we touch on this one, Katul?
Yeah, that's what I was going to say.
Yeah, great. So we see, and there was a question, there's a couple of questions in the chat a little bit about kind of what would you do with biomedical engineering? And I think that's oftentimes such a very natural question with your college career. Like anybody in your shoes is thinking the same question of, gosh, what do I do? What will I do with this major? What will I do with this degree plan? And we see a lot of variety of what students do after they graduate from our program. So we see that we've really good, our statistics are looking really good right now, partly because we're a pretty relatively small and relatively new program. And so we have a really good way of kind of keeping track of students who have recently left our program. But we see about half, so almost half of the individuals that leave our program go directly into industry and work directly in biomedical engineering related positions. So about 47%, so almost half of students that graduate our program go directly to industry. It also leaves like a really big portion of students, right, that what do they do? So we see a lot of students, there's a lot of different things that we see. We see that students get jobs that are kind of BME related. So may have some biomedical engineering related pieces, but their primary job function may not be fully in biomedical engineering. We see about, about 20 to 25% of students go directly to graduate school. So that was a question that Sierra had in the chat about, do students go on and get master's degree? And we do master's degrees, and we see that that happens pretty often, quite often. So kind of the next largest chunk of students, besides those that go directly into industry, the next largest chunk of students go into graduate school. So we see that and in that graduate school category, right, we see that there's some variance too within that of what type of graduate school students pursue. So we've had students that have pursued medical schools. We've had students that have gone to dental school. We've had students that go into biomedical engineering related degrees, as well as other type of engineering related degrees. We've got a great program at CSU that students can continue on their education from their undergraduate degrees and continue on and use a small amount of credits that you take as an undergraduate student and use those towards your graduate education if you're staying at Colorado State for that. So that is an option that students do consider oftentimes too, is staying at CSU to pursue graduate education. Beyond that, we have students that do a lot of other things too, right? That travel or have jobs kind of outside of biomedical engineering or take some time off, or that we just don't quite know yet. So there's a lot of those numbers exist there too. But we see a lot of students that go into companies like Terumo. Terumo and Medtronic are kind of in this regional area for us. Beckman Coulter, Boulder Biomed, ConMed, and then you see this list of other companies. A lot of us have probably seen the name AstraZeneca in the news. Obviously, there's lots of stuff that we're seeing in the news kind of with vaccines and COVID, and so there's a lot of cool stuff that we're seeing happen with biomedical engineering, and we know that our students are going directly into those types of positions and working directly at those companies. One of the biggest things that I think is really good to highlight with our program is really that 2-degree approach, that we have, that depth of students that have both the skill set of a traditional branch of engineering and the depth or the breadth of what biomedical engineering is. And so we really find that the employer feedback with that is really positive, is that, kind of the statement here on the bottom of the screen is that, an employer can teach somebody how to do biomedical engineering work, but not necessarily that traditional branch of engineering. And that's why we feel it's so important to bring those two together and also really play with that space of how those two connect, right? How your primary discipline connects with that biomedical engineering. So you have coursework directly related to that, those two categories. Are there any questions? I know that there's other questions about kind of internships and then unique opportunities. We're going to touch on those ones a little bit, but are there other questions about job opportunities or positions or graduate school that I can touch on a little bit more here? Okay, so seeing that there's not really any there, I'm just going to kind of move on to the next slide. We attract, Dr. Popat had mentioned this earlier, we attract some of the best students, and you all are definitely part of that. Our fall incoming class, this is a kind of a snapshot of what our fall incoming class looks like. We attract a very large amount of students who are women, which is really amazing for us. About half of our students identify as women, and that's a really amazing statistic that we love to share and promote. And we find that that's such a great piece of our biomedical engineering, is that we have this great representation of both males and females, which is a really amazing experience for students coming into our program, males and females, to be able to come into a class and feel like you are welcome, that you are represented in that class, and not feeling a little bit like, gosh, I don't know if I really fit here. We find that there's a really good fit of students with having that kind of half and half representation of males and females. We have about a quarter of our students are out-of-state students, so non-resident students. About a quarter of our students identify as culturally diverse. So again, kind of just talking to that diversity of our program, which we're really proud of. We have about a 12% of our students are first-generation students, so students who neither parents had earned bachelor's degrees. in their education experience. So there's a lot of support available to students who identify as first generation. We love to be able to get students connected to that. So if you feel like if that is an identifier that you hold, I hope that you are taking the time to ask questions and talk to people about getting those resources and getting connected. And being a first generation student can be really challenging. In pre-COVID times, we generally hold a dinner just specifically for first generation students who really feel committed to really making sure that first generation students feel they've got a place on campus and feel connected. About a quarter of our students are honors students, so participate in our honors program, which just again kind of talks about high achieving nature of our students. And then we have a lot of high academic performers. Many of our students come to our program with above 4.0 GPAs, high SAT and ACT scores. And if you're looking at these statistics and going, gosh, I don't know if I really fit into this, or, oh gosh, is this me or is this not me? Remember that these are just averages. We cover a lot of span and a big spectrum of all of these scales. And so please know that this is just a snapshot of what are kind of who is in our program, but we want to talk to all students and welcome all students into our program. The graph on the screen just shows a little bit of kind of the breakdown of the different partner majors. So right now we've got a little bit more biomed. That purple bar is the biomed mech students. And then the green bar is the biomed EE students. And then the orange bar is biomed CBE students. So kind of those different partner majors. So right now we've more kind of about a little bit more than half are biomed mechs, and then the next big chunk is going to be biomed CBEs, and then we have a pretty low enrollment in biomed EEs, but we just keep wanting that number. We just keep seeing hold steady as well. I think we're going to see it kind of grow a little bit because the world of electrical and how that interacts with the body, I think we're just really kind of learning what that looks like and what that is, and all the nuances and growth that's happening in that field. We're hoping that we see more and more students. So I've already heard you all talk about interest in robotics or neuro, and that can really be that convergence of electrical engineering and biomed can really be a part of that. Great collaboration. I'm going to kind of touch on this, and then Katul, I'll let you kind of fill in anything or details that you feel like you want to add to this. But we collaborate with a lot of different faculty and programs across the university. We are the School of Biomedical Engineering, so we're not just our own department, but what that means for us is that we collaborate with four different colleges in the university. So we're kind of a school of individuals that are made up of staff members and faculty, well, mostly just faculty members from the College of Natural Sciences, the Walter Scott Jr. College of Engineering, the College of Applied Human Sciences, and the College of Vet Med and Biomedical Sciences. So all four of those colleges, we have faculty members that are, their primary appointments are in those colleges that are part of the School of Biomedical Engineering. And then because of the uniqueness of our program, we use a lot of different facilities. So we've got facilities on our main campus, as well as the Engineering Research Center and the Veterinary Teaching Hospital. Dr. Popa, is there anything you wanted to add kind of with our collaboration with faculty? And
just, a couple of things. So that since, even though you will get a degree in engineering, that does not mean that you cannot work with somebody from any of these colleges. Because we are part of the school, which is this multidisciplinary school, you will have access to faculty in veterinary medicine, and you can actually work on a research project in a lab in veterinary medicine, or in health and exercise science, or in chemistry. So a lot of doors will be open to you when you start this program, because, as I said, biomedical engineering is multidisciplinary, and to solve these complex problems, you need expertise of a lot of different people. And, we have people who work on biomedical problems, not just engineering, but on all these other colleges. But they need engineers, because engineers build, and engineers design, and engineers optimize. And so there's always a need of engineering students and engineering professionals in many different fields of biomedical engineering.
That's one of the cool things that I feel like a lot of our students get connected to is research opportunities. And research opportunities exist certainly in the Walter Scott Jr. College of Engineering, but across the university in different departments. And like Dr. Popa is saying, kind of that what you bring to a research group or research project with your engineering background is unique, and a lot of researchers really want that perspective. And so we find that some of our students that have these really great enriching opportunities in research are actually ones that aren't doing necessarily engineering related research. They're doing a lot of other types of research. Certainly students that are doing engineering related research, they're having great opportunities and experiences too. So that's definitely not limited, but lots of great experiences exist across the university. Beyond the classroom, we're really proud of some of the programs that we are doing beyond the classroom. There's lots of great opportunities for students to get involved in internships and cooperative education experiences. So I know that was a question in the chat a little bit earlier with internships. An internship is not a requirement of part of our program. So it's not something that you are required to kind of find and do and be a part of. And for a lot of good reasons, this really makes it so there's a lot of freedom for you to be able to choose the opportunities that really fit your interests, because we know that there's a lot of wide variety that exists in biomedical engineering. So we want that variety to exist for all of our students. And because biomedical engineering is just in this kind of growth phase, there's lots of companies that are local and regional, but as well, there's just lots of companies across the nation. Because there's a lot of growth, there's also a lot of development, a lot of changes. So while we don't have a kind of a collection of internship opportunities, we've got great connections with a lot of these companies and can provide information of how to get started with internships. So though we don't have those, you know, here's this kind of prepackaged internship that you apply for, we really take a lot of time to talk with students about opportunities and really kind of put the onus on students to find those opportunities that really fit you all and what works best for you. With our cooperative education opportunity, that's an opportunity for students to use a year of time to kind of add additional time, which I know if this being already a 5-year degree program, adding additional time may not be the biggest want in that, but we've got some students that have done that and really had these great opportunities to work for a year and gain some education or gain some experience alongside their education. So there's a lot of really good opportunities there. We've talked a little about the senior design and how interdisciplinary that is and how practical that is, and that's a big highlight of our program, and mentioned a little bit about lab opportunities, and those again very multidisciplinary, interdisciplinary. Students can kind of go at any point and find different research opportunities. We find that's a really great way for students to be able to kind of grow your skill sets as well. We have a student-run student organization that's Biomedical Engineering Society. So it's a student chapter of the larger Biomedical Engineering Society group. And this is a chance for students to get connected with programs or potential employers and learn more about the field or learn about different techniques that are being used. And then we've got lots of great local and global collaborations. Certainly with the vet school, there's some opportunities for students there, a lot of faculty work and have collaborations with international research. And then we've got some great opportunities with study abroad. You can kind of see here, there's a partnership here that we have with ROMP, which is the Range of Motion Project, and a study abroad program in Ecuador. And this next slide talks a little bit further about that. But we've got an opportunity for students to study abroad in Ecuador for about a week's worth of time, where students go to Quito, Ecuador, and work with the Range of Motion Project, ROMP, and spend that entire time designing prosthetics, fitting prosthetics, working with individuals, doing some physical therapy, learning about the process of design. And what this is really amazing, what this amazing program does is allow for students to get firsthand experience with prosthetics, which is pretty rare. But it also allows students kind of see these techniques and work with individuals in a more developing area. So finding kind of lower cost solutions to prosthetics. So kind of this development engineering, which has really been an amazing program for us and a highlight of our program for sure. You can kind of see some of the pictures of students working on some of these prosthetics. So this is a really awesome opportunity that we hope all students look into, and it's open to all students. So even students who are not in our major are open to this opportunity. And unfortunately, it was not offered last summer, but it will be offered this upcoming August, which is really exciting for us.
And one thing I wanted to add is that we do also have a lot of scholarships that we offer to students. So, you know, I would strongly encourage students to think about it. You know, if you think like, oh, this is going to be something you can't afford it, we do have actually scholarships that we offer every year to, selected number of students, few students. So, you can, apply for those as well.
Well, we're kind of talking about different opportunities, and there's some questions in the chat with about internships and about jobs and about these kind of unique opportunities. Are there additional questions that you all might have that I can highlight? All right, so let me throw a different question out to the group so we can just, again, try and promote some of that interaction. But what are some of the things that you've learned about that you find to be really exciting about our program?
Certainly all of the options that it presents after we graduate, and even all the opportunities that it sounds like we have while we're at CSU studying. It sounds like it's a really open education, and it can go a lot of different ways. It's very versatile in that way.
Yeah, great. Thanks so much for sharing, Jackson. Absolutely. I think that versatility, I think we've highlighted that a lot, the versatility and that openness, and certainly that kind of interdisciplinary piece of how we really work together in different minds, kind of create this great biomedical engineering world that we live in. So yeah, thanks again for sharing. We are ABET accredited. This may be a concern of some of yours. For some of you may kind of be wondering, well, what is this? There's an accreditation agency that accredits engineering programs, and it's called ABET. And we are ABET accredited, and kind of one of our highlights is that we are the first accredited biomedical engineering program in the state of Colorado. And then as well, we're the first accredited biomedical engineering that has this dual degree approach and this 2-degree approach. And again, we've talked a little bit about how important that is to us. And it kind of goes, we've had kind of a nod, a pat on our back with making this kind of the first accredited program of its kind. All right, so it's kind of the end of the information that we have. Our information is here in terms of email and website. I hope you do take the time to look a little bit on our website with different, look at details about our program. I'm going to put my information or my email address in the chat because I am the kind of primary contact again for first year students as well as any prospective students. So if you have any questions about our program and want to kind of get more information, I'll be a great point of contact for you. But let's, we've got some time, and we'll be here for as long as people would like, or at least I will. We've got some time to kind of ask questions before I kind of turn it all over to you to ask any additional questions. Just a reminder, if you're wanting to learn a little bit more about our program, this is kind of the Biomedical Engineering Day as part of Engineering Exploration Week. And so the other events that we are hosting is we're going to have a student panel at 1, so we can hear from students like Katie who talk a little bit about their kind of day in the life experiences. And then as well, we've got a faculty panel at 2, and that will give you a chance to hear from faculty like Dr. Popat about kind of the highlights of our program, because those are really the individuals that you'll interact with often. So we've got those 2 things going on. Looks like there's a question in the chat. Any advice for students going into BME majors and how to handle the rigor of these programs? I could certainly probably talk ad nauseum on this question, but I don't know if I'm the most qualified individual to talk about this. I don't know if Katie, you might have a few thoughts about your kind of experience in the rigor of biomed.
Yeah, that's a good question. That was definitely something I was concerned about coming into a dual degree engineering program. It's definitely rigorous, and it's a lot of coursework, and it can be very challenging at points. But I would say definitely don't be afraid to ask questions. Number 1, I was never huge on asking questions, and that's just something that is not very helpful if you're going into a rigorous program. So asking questions helps a lot, and getting to know your professors. I know my first year, I was definitely intimidated by almost every single professor I had, but they are human too, and they're teaching you for a reason. They want to see you be successful, and they want you to learn. It's really up to you kind of what you get out of the program. Like what you put in is what you get out. So remembering that they're there for you and getting help when you need it is kind of what allowed me to get through these 5 years, and also leaning on other students. I love that CSU is very community oriented. I never felt like I was competing with the student next to me. It was more of a kind of, I'm here to support you, you're here to support me, let's get through this together mentality. And so getting to know your classmates, forming those study groups, and then reaching out to faculty when you need help and attending their office hours that they have is kind of what helped me. And I think on top of like meeting the students in your classes and getting close to them, that is just like a good reminder of, you know, why you started this major in the first place. And so taking a step back each semester and being like, okay, why did I choose this program, and where do I want to be, you know, in 5 to 10 years after this program, and kind of just remembering what motivated you to do this, that at least helped me a lot, because the end goal is kind of, I want to help people. I want to work on devices and medicine to help them. And this program is going to get me there. So that kind of gave me that extra push and motivation when I needed it as well.
That's great advice. Thanks, Katie.
Yeah.
Great. Other questions? Well, you all hopefully think of a question that you may have. I'm going to touch a little bit about the questions again that were in the chat. I think I touched on them just briefly, but we had the question about biomed students going on to master's degree after the dual degree program. The answer is definitely yes. Often though, we find that the 2 engineering degrees alone are great preparation for industry work. And so we're not finding right now that there's kind of this requirement or expectation that individuals have that master's degree, and that the preparation that you'll get and the hands-on experiences that you'll have in your dual degree will be well enough to suit you kind of into that first part of your career. Medical school, kind of ergo to medical school, yes, the number of students that have gone to medical school is relatively low. We find that a lot of students that really want to pursue medical school are ones that really want more of that kind of science, want more of the biology and understanding of the science of life rather than the applications of engineering. So we do find a lot of students kind of choose that route with majors rather than stick with our major. But what we're seeing, and this is just the growth of biomedical engineering, is kind of this new philosophy of engineering as applied to medical school, as applied to practicing medicine. So kind of the idea of being a physicianeer, right? Both physician and engineer, and kind of really understanding the medical devices that are in an operating room or in a medical setting. Having that knowledge of being an engineer and a physician, I think, is really uniquely set students apart, and really creates almost a different skill set, a unique skill set that students can have as being in that medical school world. Kind of had the question about internships and job opportunities, talked a little bit about that. It's really open-ended, so there's not really direct answers of what types of internships or job opportunities. Again, we can talk about what students, companies that students have done, but we do see a lot of students that go into kind of research and development, researching different medical devices and solutions, also kind of quality. So being able to quality understand how effective a tool is, and if it's doing its job, basically. So that's a big thing that we see students do. And internships are really, sometimes internships, especially the ones that may exist over probably a summer, is really just kind of learning a little bit about culture, right? And engineering culture and working in positions and what a day-to-day job is like. So that's a lot of what students do in internships. Dr. Popat or Katie, do you have any additional information that you'd want to share about internships?
No, I think you pretty much covered everything. You know, our students, you know, one of the things that I do in the freshman class that I teach is I actually have like a extra credit assignment for students to go to career fair. And the reason to do that is that you get used to going to career fairs. And kind of see what's out there, because that's how you will get into, you know, knowing more about, you know, where the internship positions are and what options you have. So the reason for me to, you know, kind of tell students and give them extra credit is so that you guys get used to. But you'll have a lot of so we have like a lot of organizations that on campus where you can sign up and you'll get notifications of what companies are coming. We have the BME student chapter. They do a lot of activities related to professional development, and anything and everything that you can get involved in is going to be beneficial. And it is a rigorous degree program. It's a degree program where you're going to take a lot of courses, and I'm going to be honest that some of these courses will be hard. Some of these courses, will take a lot of time. You'll have to study a lot. But I always tell students, have patience, have faith, and know what you want to achieve. And as far as you're clear on that, everything else is just a hurdle that you're going to pass and be successful later on. And that's always very important to remember, that what your goal is, what do you want to do after you graduate, and what your passion is. And as far as you keep that in mind, you will come across many successes in your 5 years. You'll come across a few hurdles, but that's part of it. If you don't have that, then you don't enjoy those successes. So I always tell students, take this as a part of experience, and look forward to those hard times and good times, because at the end, once you graduate, you'll be successful, and then you'll be in a profession that you truly enjoy and would enjoy working for the rest of your life. So that's what I would say.
Mm-hmm. And I think that's an interesting point too, about kind of this. Right now, you all are kind of deciding and determining what is the best path, and if biomedical engineering is the best path for you. We've got Katie's perspective of being, in your 5th year, and kind of all the things that you've experienced along your way, right? And your journey and the rigor of that, right? And uniquely, I think that, and again, this is from my perspective of being an advisor for first-year students, I think that the first year is one of the hardest years, if not probably the hardest, because not only in your first year, you're really learning about yourself as an individual and kind of your college academic self, but also you're learning about what is the best fit, and you have a lot of transitions that make college and make academics pretty challenging. And so I think that advice that both Dr. Popat and Katie are sharing is really about keeping that end goal in mind is really true, because in order to kind of stick with this difficult program is really pushing through that first year hurdle of kind of, in these classes, it may not all connect, and may not all be stuff you love, and really kind of saying goodbye to that person that you were and kind of becoming this new college academic, which is a challenging year. So kind of sticking with it, I think that advice is really true, and given to you all kind of coming into that maybe first year experience of what college is going to be like, and kind of why it's such a heavy piece of advice. Really is just being able to kind of stick with that. And then the last thing is kind of just some of the best or most unique opportunities. We touched a little bit about ROMP. We also have a really cool partnership with the Medical Center of the Rockies, where students can go and learn a little bit about kind of getting some hands-on experiences in the medical setting, and have rotations in different areas in working with different doctors and physicians, and learning about medicine. That can be a really cool experience for students who are interested in medical school, or who are just really interested in learning more about medical devices, and learning about how medicine is used with kind of the engineering kind of together. So that's one of the cool things, one of the other cool things. And as well, one of the things that we like to highlight, and again, there's not direct connections or not a direct program for research. We see a lot of students get really connected to research and kind of gain experiences, but also gain just a lot of different types of experience, and getting involved on campus can be really valuable for students too. So I feel like we kind of touched everything on the chat. Again, I'm going to create just a teensy bit of space before we all sign off. I'm going to create a little bit of space just if there's any additional questions that are hanging out there. You can chat them or shout them out.
This is for Katie. I'm just wondering, what's like your favorite project or research opportunity or class that you've experienced at CSU?
Yeah, good question. So I'll do my favorite class and my favorite project. So I think my favorite class was actually the biomedical engineering lab. And so in your third year, maybe fourth, depending on how your schedule is, you are in a project-based class for a whole semester. And I love this class because you're with all different biomedical engineering students. So I'm personally partnering with chemical and biological, but I got to work with students in mechanical engineering and electrical engineering, which was awesome because they looked at questions and problems way differently than I did. And that's just something that's really fascinating about engineering, and especially about biomedical engineering, is everyone brings a different perspective to these problems, and everyone has a different way of like approaching a solution. And that leaves a lot of room for engagement, collaboration, and just like optimizing kind of a device or a solution. And so in this class, you got to do research-based problems, and then you got to do experimental-based. And so one of my favorite experimental projects was testing the as seen on TV exercise equipment. And so disclaimer, they don't work, don't spend your money, not worth it. But we got to attach electrodes all over different muscles in our body. And then we've used these exercise equipment to see if they were actually engaging and activating our muscle. So we got to design and kind of test out that whole experiment from scratch on our own. So you're kind of gaining really good skills for that design aspect of a project. And then we got to interpret and analyze our results as well. And so it was a really nice kind of full circle of what kind of a product life cycle looks like almost. You are starting from scratch with the design, you're actually carrying out the experiment and then analyzing your results afterwards to see if there's significant. And it was just a really fun project that it wasn't as like current pressing issue in biomedical engineering, but it was a fun way to get that hands-on application from the classroom setting. And so with that class, you had a lot of projects that were current issues. So we had one where we were researching pancreatic cancer screening methods. And the issue with that is that these screening methods catch pancreatic cancer really late stage. And these individuals don't have a very high survival rate at that point. And so this is something that scientists, doctors, engineers, all of them are researching right now to try and figure out a better way to diagnose pancreatic cancer. And we got to kind of work on that and come up with our own solution in class. And so I just love that the biomedical engineering program is constantly feeding in stuff that's happening in the outside world. And it feels like you're doing important work, even though you're still an undergraduate student. So that was a bit loaded, but I would say my favorite project is senior design. One of the coolest things is that your senior design project in this program is biomedical engineering. And like Dr. Popette said, we have a lot of companies come in or different faculty around the university that are doing some kind of biomedical research. And you're getting to work on a product that's could be going to market or could actually be used by that company. So that's really neat because your work as a student could go towards something that a patient might see. And so my project is through a faculty member at CSU, and I loved it. I'm getting hands-on research experience. So actually in a lab, working with different experiments, different assays. And I just love that I'm getting that experience in my undergraduate, and it might actually be used later in point of care diagnostics a while down the road. But it's through an NIH grant. So I'm actually working on like real research. So I definitely love that. And I love how relevant my project is because right now, especially with COVID-19, there's a lot of areas that don't even have access to proper testing. So this is an issue when you're trying to control the spread of the virus. And so one of the great things about my project is that if this actually works, you can bring all of these testings to different countries, even to different places within the United States, and kind of help mitigate that spread and help individuals, you know, be diagnosed with viral diseases, I guess, which isn't great, but it's great in terms of trying to control a pandemic like we're currently in. So
yeah, that's cool. Good question. Other questions? All right, but I also want to be mindful of time. We've kind of gone a little bit over, so if y'all need to head out, that makes sense. I hope to see you all, kind of like I said at the other panels. We have one at 1 with students and one at 1 p.m. with students and another at 2 p.m. with faculty. So I hope to see you all. And if you would like to be to join those, you can, I think, sign up in Slate, Katie, or not in Slate, but through the link.
Yeah, so I think you can just sign up the same way you signed up for this session for Engineering Exploration Week. You can do the same for all the other sessions as well.
Great, cool. Well, thank you all for joining us. Let us know if you've got questions or chat. My information is in the chat. So hopefully you have a great day. Take care.
Thank you. Bye.
Bye, everyone.
Thank you guys.
Yeah, thanks. Thanks for asking questions.